Hello, I'm Betty, a math educator from South Carolina. I'm here with Judy, a math educator from Colorado. We're going to explore the factored form of a quadratic function. This activity is based on the second part of an activity called Vertex and factored forms of quadratic functions. It's located in Math-Inspired in the education.ti.com activities section. The TI-Nspire document you see to your left is available, as well as teacher notes and student activity sheets for the activity. You may have studied various forms of quadratic functions before in various math courses. The standard form of a quadratic function is shown, the vertex form of a quadratic function. And today, again, we're going to look at the factored form of a quadratic function. F of x equals a multiplied by x minus r times x minus s. On page 2.1 of the TI-Nspire document, we see that we have a factored form, a multiplied by x minus r times x minus s up at the top of the page. A currently has a value of 1, r is 2, and s is 4. Note at the bottom of the page, we have the factored form with the values substituted in for a, r, and s. Currently, the value of a is 1. The graph of the quadratic opens up. And now we're going to ask Judy to change the value of a and let you observe any changes in the graph of the function. She's increasing the value of a. The value of a, of course, can also be decreased. We cannot use 0 for a, of course, because if 0 was the multiplier of these two factors, we would have the function f of x equals 0, a constant function. But a quadratic has negative values or positive values for a. So we'd like to ask you to pause the video and think about when the value of a was changed, what points on the graph remained fixed. Please write down your response and then return to the video. You may have noted that the changes in a certainly affected whether the parabola opened up or down. Also, it affected the shape of the graph. But what did not change was the values of the x-intercepts. The factors remained x minus 2 and x minus 4. And the values of r and s remained 2 and 4. These are the zeros of the function, and they did not change when a was changed. Let's now look at what happens if the values of r and s are changed. We'd like you to consider these three questions. We'll give you a chance to read them before Judy changes the values of r and s, and then you'll be able to think about what's happening as she does change those values. Want to think about how the changes affect the graph, how they affect the factored form of the quadratic function, shown in the lower part of the screen to your left, and how did the changes affect the zeros of the function. So now Judy's going to change the value of r and also then the value of s and let you think about these three questions. Please pause your video and think about these three questions. Jot down your thoughts, and when you've had a chance to respond, please return to the video. Hopefully you noted that as r and s changed, the factored form changed accordingly. The zeros changed. Note here that when one of the zeros is located at a negative number, or even both of them at a negative number, our factors become x plus 1 and x plus 3 in this case, because we had x minus a negative 1 and x minus a negative 3. In this case, if one factor is negative, one x-intercept has a negative value, and one x-intercept has a value. This is how the factored form looks. X minus the negative 1 is x plus 1, and then x minus 3. Let's summarize this on the next page. The factored form is given again at the top of the page. And to review, the ordered pairs R0 and S0 are the x-intercepts, and R and S are the zeros of the quadratic function. Please look at the graph on the left. R is equal to -1, S is equal to 3. Our ordered pairs for our x-intercepts are -1, 0, and 3, 0, and the factored form is shown at the bottom. Think about where the vertex is on this graph. If we have a value of -1 for one of our zeros and +3 for the other, look at the location of the vertex. It appears that the x value of the vertex is at +1. Think about any relationship between those values, the R, the S, which are the zeros, and the x value of the vertex. Let's record this and think about it. But before we do that, we're going to ask you to think about this factored form. So we'd like for you to write the factored form of this equation and identify the x-intercepts and the zeros of the function. And then we'll record this data and think about any relationships or patterns you might see. After you've had a chance to write the equation in factored form and identify the x-intercepts and zeros, please return to the video. Hopefully you first noted that on the right-hand side of the equation, 2 is a common term. Judy's going to start out writing the factored form by factoring 2 out of the trinomial. So we'll have 2 multiplied by x squared plus 4x plus 3. Then we can factor the trinomial, be 2 multiplied by x plus 3 times x plus 1. And of course, you may have written that as 2 multiplied by x plus 1 times x plus 3, with the commutative property, the order of those two factors does not matter. So our x-intercepts would be at -3, 0, and at -1, 0. So Judy's going to change the R value and the S value to indicate this after making the A value equal to 2. So one of our factors is -1, and the other factor is -3. So notice, please, that we do have our zeros, and of course, those were computed by setting each factor equal to 0. For example, if x plus 3 is equal to 0, x is equal to -3. If x plus 1 is equal to 0, x is equal to -1. So looking at this graph as we did a moment ago, how do you think the location of the vertex relates to these zeros? We had a little hint of it on the last graph, but we didn't really go too much in depth with it. Right here, it appears that the x value of the vertex is at -2. You could confirm that algebraically using your equation on the right. And how does that relate to our two zeros? Let's record this data and think about what relationship we may have. So Judy's going to record the zeros. We use the braces and a comma between each zero. -3, -1 are our two zeros. And it appears that the x value of the vertex is at -2. Again, you could confirm this algebraically. Let's look at another example. In this next example, Judy's going to change the R value to 3 and the S value to 5. Look at the graph and think about the x value of the vertex. You know that the vertex is the lowest point on this graph. It opens up. We have our zeros of 3 and 5, and the tick marks on the graph are at 1, are ones. So we count 1, 2, 3, 4. It appears the x value of the vertex is at 4. Again, this could be confirmed algebraically using the equation shown on the left at the bottom. Let's do 2 more zeros. Let's make r equal to 1 and s equal to 3. Notice your factors at the bottom of the page on the left. So our zeros are now 1 and 3. And it appears the x value of the vertex is located at x equals to 2. Are you seeing a pattern? Think about it for a minute. Let's do one more. We'll change r to -1 and s to 2. Our factors you see below, our zeros are -1 and 2. And now it appears that the x value of the vertex is between 0 and 1, perhaps 1/2. And does 1/2 make sense to you? Perhaps the easiest one to look at first is the 3 and 5 zeros, where the x value of the vertex is 4. With 1 and 3, the x value of the vertex was 2. So you may observe that if you add the 2 zeros of the function, r and s added together, and divide that by 2, we have the x value of the vertex. Hopefully that makes sense graphically, and of course we can prove it algebraically. Now let's consider another situation that might occur. What if r and s are equal? So let's leave the s value at 2, and we'll change r to 2. And what do you observe now about the graph of this quadratic function? Take just a moment and write down your thought. You don't necessarily need to pause the video, but if you wish to, please do. In this case, the zeros are the same. Look at the factors on the bottom left-hand side, and you see, of course, that the factors are the same. We could change the a value, and as we determined earlier, that would not affect the graph as far as the zeros and the factors go, other than the coefficient of the factors x minus 2. And so the a value changes, but x minus 2 does not, and the zeros remain the same. Think about the x value of the vertex. In this case, if you add the 2 zeros, 2 plus 2, and divide by 2, we still have x equals to 2 for the x value of the vertex. Let's now look at a challenge where we can ask you to write an equation. A quadratic function has zeros at -2 and 3, at x equals to -2 and x equals to 3. We'd like you to write a quadratic function of the form f of x equals a multiplied by x minus r times x minus s. So use your factored form and write a quadratic function with these 2 zeros. Please pause the video and come back when you've had a chance to write your function. Since the a value was not given, this might make us think that there could be multiple answers to this problem. Suppose a was equal to 3. If a is equal to 3, our function would be f of x equals -3, and the -3 is going to be multiplied by x minus a -2. And of course, we can write that as x plus 2 as well, multiplied by x minus 3. So we can think of that first factor as x plus 2. And remember, of course, our zeros are at -2 and 3. So think about whether this satisfies the condition given. And Judy's going to change the a value to -3. And let's look at the graph of this particular function. You may have chosen an a value that was positive rather than negative. And the r value is -2, the first r value. and the second R value is positive 3. So this equation is shown below, as Judy had written on the right, and this is a graph with these two zeros. We'd like to challenge you now to write another function and think about how many functions there could be that satisfy these conditions of these zeros. So hopefully yours will be different from the one shown. And of course, you may have chosen a positive a at first. Think of other a's you could use, perhaps not even an integer value for a. For other videos, please go to the TI Education YouTube channel.